Good morning, class. Geometry class, that is. I realize that I have a face for radio. However, I know you guys will love to see me every other day with this mug. Yeah. So anyway, starting lesson 7.1. I'm not sure if this is a test run or we're going to roll with it, but here we go. 7.1, ratios and proportions, page 461. Page 461. When we're finished with the video, the assignment will be on Google Classroom. And if you have any questions between now and Wednesday, just text me, email, call, whatever you need to do. Otherwise, on Wednesday morning, when we get together for our short meeting at 8 o'clock on Wednesday, come with questions then, and then we'll just kind of iron it out and figure it out. So, ratios and proportions. Once again, if you didn't get your test and assignments in on Friday, no worries. Just get it in at the end of this week, and we'll figure it all out. So no stress. So here we go. Page 461. Write and use ratios. As we see, a ratio is a comparison of two quantities using division. The ratio of quantities is expressed A and B, can be expressed as A to B, A colon B, or A over B. And ratios are usually going to be expressed in simplest form. Okay, simplest form. We see that example at the top of page 461. Jumping down to the guided practice question. We have a ratio in Logan's High School. There are 190 teachers and 2650 students. What is the approximate student to teacher ratio, right? So we could say student to teacher, student colon teacher, or student to teacher. We're using in this example a fraction. So student to teacher, we know that their students is 2650, and I think the teachers, they say, is 190. So that comes out to a 14 to 1 ratio. Okay, 14 to 1. This is in unit rate. Okay, that means it's to 1. 14 to 1. Think about if we have, if we travel 700 miles in 10 hours, you wouldn't ratio that at 700 to 10. You would get it down to a unit rate of 700 divided by 10 would be 70 miles per hour. Okay, so that's a unit rate. Bottom of page 461, we have extended ratios can be used to compare 3 or more quantities. And we can set it up in terms of using the colons, A to B to C, like this. Okay, and we're going to turn the page and we're going to go to 462. Okay, we're going to go to 462 and we're going to look at the top of the page in terms of example 2. Okay, example 2. When we, in this example, we know that the interior angles of a triangle are 180. The ratio of the sides of the triangle, okay, is 3 to 4 to 5. That's the ratio. So we have to add a variable to that to where we may say 3x plus 4x plus 5x equals the total. When we add these up, we get 12x equals 180. Divide by 12. X is going to equal what, Cole? Cole, what's that going to equal? Cole, are you awake? 15, yeah. I know you knew that. So that's how we're doing extended ratios. When we look at guided practice 2, we read middle page 462. In a triangle, the ratio of the measures of the sides is 2, 2, 3, and the perimeter is 392. Okay, 392. So we know if it's going to equal 392, we put it equal to 392. And what is the ratio together? The two sides are 2 times 2 times 3. So my ratio originally was 2 to 2 to 3. So I add a variable to that. What the variable does is tells me that it's going to be a similar triangle. Okay? It's going to be a similar triangle. It's just a question of how big that triangle is going to be. And that's what the variable is going to tell me. Okay? I could have had my total be 800. Then my variable or my constant is going to be, once we get a number here, that's going to be my constant, and we're good to go on it. So we add those together. 2 plus 2 plus 3, 7x equals 392. And we come up with x equals, what is 392 divided by 7? I believe it's 56. So then the question is, the ultimate question is, find the length of the longest side. So now we use our variable. 56 times 3 is going to be 168. Okay, is going to be 168 is going to be, and don't forget to put your measurement in. And we had inches here, so we put our measurement, always put our measurement in here. So 168 inches. Okay, so that's extended ratios. Extended ratios. Now we're going to look at proportions. Proportion is basically just going to be two ratios equal to each other. Okay? Two ratios equal to each other. Let's read middle of page 462. An equation stating that two ratios are equal is called a proportion. In the proportion, A over B equals C over D. The numbers A and D are called the extremes, while the numbers B and C are called the means of the proportion. We see the little diagram there. The product of the extremes and the product of the means are called cross products. Okay, cross products. All right, so we're going to take a look at page 463, go through a couple of examples, and you're going to be good to go. X over 4 equals 11 over negative 6. All right, we multiply the means together. 4 times 11. We multiply the extremes together. Negative 6 times x. My extremes, obviously solving. Okay, for that, my answer in simplified form, negative 22 over 3, or what do we have? 7 1/3. Okay, so that's guided practice 3A. Let's take a look at guided practice 3B. Negative 4 over 7 equals 6 over 2y plus 5. Now when we have a binomial in this, we need to distribute. Make sure we write it out when we have a binomial so we're not missing any steps. We could have just said 7 times 6 is 42. Now we know we need to distribute the negative 4. Okay, we need to distribute the negative 4. Okay, to both terms. We add 20 to both sides. divide by negative 8. Remember, 62 over negative 8, we always want to simplify it down. 2 goes into both, negative 31 over 4. If you want to put that in a decimal, that's fine as well. And one last one. Here we have both binomials on both sides, and we do the same thing. X plus 4. We're going to multiply the extremes. Multiply 7x plus 28 equals 9z minus 9. And you can simplify that, do your algebra to get your answer, which would have been 37 over 2. Now, be careful with some of the homework assignments and homework problems. You may have something that turns out to be a quadratic. Okay, so you may have something that turns out to be a quadratic on one side. Okay, and then you might have something else on the other side, which might be x minus something. If you have a quadratic, bring everything over to the other side. X squared minus 9x plus 15. And then to solve it, you have to solve it either by factoring or using the quadratic formula. Okay? Quadratic formula. All right, so that's our lesson today on ratios and proportions. And your assignment will be on Google Classroom. Let me know if you have any questions. Peace out.